Hi friends, today I am giving a lecture on left factoring in top-down parsing. Left factoring is one important concept during parsing in top-down parsing. What is left factoring? What is the purpose of left factoring? How to detect the left factoring in a given grammar and how to eliminate the left factoring in a given grammar. These are the points that we are discussed in this video. First of all, what is left factoring? Suppose a grammar has a production has the form A tends to alpha beta 1 or alpha beta 2. Here alpha is common. Alpha is common. In the right hand side of a production, okay, the first part is alpha beta 1 or second part is alpha beta 2. Here alpha is same in the first part and alpha is also same in the second part. Okay, alpha is common in the right hand side production. Suppose if the given grammar has the production is in the form of A tends to alpha beta 1 or alpha beta 2. So then this type of production can be replaced with the following productions. So that is A tends to alpha A dash tends to beta 1 or beta 2. Okay, whenever the given grammar has the production is in the form of A tends to alpha beta 1 or alpha beta 2, then that productions can be replaced with the following productions. A tends to alpha A dash tends to beta 1 or beta 2. Okay. Now we go for general formula. General formula is if a production is in the form of A tends to alpha beta 1 or alpha beta 2 up to alpha beta n or gamma. Okay, then this production can be replaced with A tends to alpha A dash or gamma, then A dash tends to beta 1 or beta 2 or beta 3 up to beta n. Okay, where gamma is all alternatives in the right hand side of a production that do not begin with alpha. Okay, so here this part starts with alpha, this part starts with alpha, this part starts with alpha. Okay, here gamma represents all the alternatives that do not begin with alpha. So that represents the gamma. So these are the productions that we are replaced by this production. So this is the general formula. Okay. Now what is the purpose of eliminating left factoring? Okay. Mainly left factoring is a one type of grammar transformation. After transforming the given grammar into another transformation, that transformed grammar is suitable for predictive or top-down parsing. Okay, suppose the given grammar is in the form, then this grammar can be transformed into another grammar. So this grammar is suitable for predictive or top-down parsing. This grammar is not suitable for predictive or top-down parsing. Okay, this grammar can be transformed into this form. This form is suitable for producing a predictive or top-down parsing. This is the main purpose of left factoring. Okay, hence we can simply say that left factoring is a one type of grammar transformation that is useful for producing a grammar suitable for predictive or top-down parsing. Okay, next we go for example. Consider the given grammar S tends to small I capital E small t capital S, or small I capital E small t capital S small e capital S, or A and E tends to B. Okay, now suppose when we can say that this grammar has a left factoring. Okay, when the given grammar has two productions, first we are considering this production. This production is in the form of A tends to alpha beta 1 or alpha beta 2 up to alpha beta n or gamma. So this production is compared with this production. Here A is equal to S. A is equal to S tends to IETS. IETS, why we are observing this part and this part, we are observing this part and this part. What is the common? Here IETS. Here this part and this part are observed. What is the common between them? Alpha is the common. Now observing the common part in these two parts. Okay, IETS is the common part. So now alpha is equal to IETS. Alpha is equal to IETS. Here IETS is alpha, but beta 1 is not there. Then beta 1 is equal to epsilon. Beta 1 is equal to epsilon. So epsilon is multiplied with IETS is equal to IETS. Okay. Next one, alpha is same IETS, and beta 2 is equal to ES, because this is alpha, this is also alpha. Here beta 1 is epsilon and beta 2 is ES. Okay. Next, gamma is equal to A. Gamma is equal to A. Gamma is nothing but the parts that do not start with alpha. Here the third part do not start with alpha. Then we can say that gamma is equal to A. So now this production is in the form of this production. So then hence we can say that this production is said to have left factoring. Okay. Now this production is replaced with these two productions. Okay. These two productions. The first production is A tends to, here A is equal to S. S tends to alpha. Alpha is nothing but IETS. A dash nothing but S dash slash or gamma. Gamma is nothing but A. Okay. Next, A dash is nothing but S dash tends to beta 1. Beta 1 is epsilon, or beta 2 is ES. Okay. Now after converting this production into this form by using this rule. Okay. Next, the second production, it is not in the form of this one or this one. So hence we can say that this production does not have any left factoring. So directly we can write this production, this one. Okay. Now from these two productions, after eliminating the left factoring, then this is the output. Okay. So this is the introduction about the left factoring. Now in the second part of the video, we have to solve some example problems how to eliminate the left factoring. Okay. Thank you for watching this video. If you like this video, please share this video to your friends and classmates. If you like this video, please subscribe my channel name Divvela Srinivasa Rao. Hi friends, today I am giving a lecture on left factoring in compiler design. Left factoring is one of the most important concept while parsing top-down parser. Okay, so for parsing the given grammar using top-down parsing, first we have to eliminate the left factoring. Okay, in the previous video we are already discussed about what is left factoring, how to detect the left factoring and how to eliminate the left factoring, that we are discussed in the previous video. Now in this video we have to solve some example problems how to eliminate the left factoring in a given grammar. Okay, so now consider the first example problem. Okay, this is the given grammar. Okay, so first the given grammar is compared with this production or this production. If the given grammar is in the form of this production, then that grammar can be replaced with these two productions. So for eliminating the left recursion, suppose the given grammar is compared with this production. If it is in the form of this production, then we have to replace this production with these two productions for eliminating the left recursion. Okay, so by observing this given production, the given production is in the form of this one. Okay, now this production is compared with this production. Here this is A, and here what is the common prefix there? That is small a. The common prefix can be represented by alpha. So this is alpha, this is alpha, and this is alpha. Okay, next beta 1 is nothing but after alpha, what is the remaining combination is there? It can be represented as beta 1. After alpha, what is the combination of terminals and not terminals? That can be represented as beta. Then after alpha, what is the combination of terminals and non-terminals? It can be represented as beta 3. Okay, now here there is no gamma is there. Okay, therefore gamma is equal to infinity. Next, alpha is equal to A. Beta 1 is equal to AB. Beta 2 is equal to AC. Beta 3 is equal to BC. Okay, now this production is compared with this production. So these are the values. Now this production can be replaced with these two productions. So first one is A tends to alpha A dash. Here alpha is nothing but A, small a. A dash is nothing but A dash slash gamma. Gamma is nothing but epsilon. Okay. Next, second production, A dash tends to beta 1. Beta 1 is AB slash beta 2 is AC. Next, beta 3 is BC. Okay. Now, observing this production, okay, there is a common prefix is there. Okay, so here this is 1 and this is 2. Okay. Now by observing production 2, it is in the form of A tends to alpha beta 1, alpha beta 2 up to gamma. Okay. So now again it can be replaced with, so here A dash tends to AB, AC, BC. Okay. Now here this is A and this is alpha and this is alpha and this is gamma, and only this one is beta 1 and this one is beta 2. Okay. Now this production can be replaced with, so A tends to, here A tends to alpha. Alpha is nothing but capital A. A tends is nothing but A dash. Alpha is nothing but A. Next one is A dash. So that is A dash whole dash by gamma. Gamma is nothing but BC. Okay. Next one is A dash whole dash is beta 1. Beta 1 is B. Beta 2. Beta 2 is C. Beta 2 is B or C. Okay. So now A dash whole dash can be determined as S. So now the above productions can be written as, so first one is the above productions after eliminating left factoring. Okay. So this production is same. A tends to A dash by epsilon. Second production, A dash tends to capital A dash whole dash can be written as S by BC. Next one is A dash whole dash is nothing but S tends to B or C. Okay. So after eliminating the left recursion, so this production is in the form of this one. Okay. So these are the final production after eliminating left factoring. Okay. Now go to the second example problem. So S tends to small a capital A, small d by small a capital B. A tends to A by AB, B tends to CCD by DDC. Okay. First one, we are taking the first one. S tends to small a capital A, small d by small a capital B. Okay. So now it is in the form of, so here this is A, here in both one common prefix is small a, this is alpha and this is alpha, and AD is beta 1 and B is beta 2. Okay, so according to this one, this production is in the form of this one. Here gamma is equal to epsilon because there is no gamma term is there. Now the above production becomes so A tends to, A is nothing but S tends to alpha A dash. Alpha is nothing but A dash is nothing but S dash. Okay. Now S dash tends to beta 1. Beta 1 is AD by beta 2 is nothing but B. Okay. So after eliminating the left factoring, this production becomes this one. Okay. Now go for second one. Second production. So A tends to small a by small a B. Okay. Now this production is A. Common term is alpha. Here the common term is alpha and this is beta 2. Here beta 1 is equal to epsilon. Okay, and gamma is also epsilon. Okay, so now the above production becomes A tends to alpha A dash. Alpha is nothing but A dash is nothing but A dash by gamma. Gamma is nothing but epsilon. Okay. Next one, A dash tends to alpha 1. Beta 1. Beta 1 is epsilon by beta 2 is B. Okay. So this is the first production and this is the second production. Now go to the third production. Third production is B tends to CCD by DDC. Okay. Here there is no common prefix is there. So this production does not have any left factoring. So therefore, after eliminating left factoring, in above grammar, the productions are first one is S tends to A S dash, comma, S dash tends to capital A small d by capital B. Next one, A tends to A dash by epsilon. Next, A dash tends to epsilon by B. Next, B tends to CCD by DDC. Okay, this is the final answer after eliminating the left factoring. Okay, so for this grammar, the final productions after eliminating the left factoring is this one. So in this way, we have to solve any problem the given grammar has left factoring. Okay, thank you for watching this video. If you like this video, please share this video to your friends and classmates. If you like this video, please subscribe my channel name. So Divvela Srinivasarao. Thank you.